Okay, you guys, we're going to be doing 8.1 angles of polygons. In your book, it has all of the angles listed on a table on page 404. And for this table, you could memorize a bunch of stuff, but I don't like memorizing, so I'd rather know what a formula is and how to break it apart. So some of you guys may have seen this formula before, and it might seem new to some of you guys, but it's going to be our first theorem that we're going to look at in this chapter. And the theorem is called the interior angle sum theorem. The interior angle sum theorem says that the sum of the measures of any of the interior angles in a polygon is 180 times n minus 2. And if you'd like to read about this more, it can be found on page 404. Okay, so I'm going to write out what all of our formulas are, and then I'm going to show you guys how we're going to use those. So the next formula that we're going to look at is the exterior. Now this is the interior angle sum theorem I'm going to come back to, and then the next theorem is the exterior angle sum theorem. Okay, and this one can be found on page 406 if you wanted to see that in your book. And this is saying that the sum of the exterior angles is simply 360 degrees. Okay, so exterior angles, the sum of them is 360 degrees. So we have our two formulas, and you might be looking at this thinking, well, what's an interior and exterior angle? So let's look at what that is. Let's say that we have any polygon, and I'm going to use a hexagon. And it doesn't matter if it's regular or not. Mine looks regular, but it's not perfect, so it obviously isn't. But it doesn't even matter. All of these angles that are inside here, these are all of your interior angles because they're inside your polygon. Now if I were to turn this into a ninja star and just expand all of my sides here, so you see how it looks like a ninja star or even like a pinwheel? Well, this angle right here is the exterior angle. So all of these that are right here are my exterior angles, and all of these in here are my interior angles. Now, if I were to look at just this right here, this interior angle and this exterior angle, what do you notice that the two angles together are on? What do you notice they're on? They are on a line. So that means that some extra, I'm going to call these helpful formulas because they're not formulas that are theorems, so they're stuff that you would just derive based off of this. So the first one is that an exterior angle plus an interior angle form a linear pair, which means that they add up to 180 degrees. Okay, now the next thing is, because they add up to 180 degrees, let's look at the formula for just finding one interior angle, because these two formulas right here give us the sum, But what if I just want to find one interior angle and one exterior angle? So it's easier to start with looking at our exterior angle. If you notice, there are 1, 2, 3, 4, 5, 6, and this is a hexagon. So the number of sides for this hexagon is 6. So if I wanted to find out which each one of these is, for a regular, this only works for a regular polygon. So in a regular polygon, one exterior angle is equal to the 360 degrees that they all add up to, divided by the number of sides, because the number of sides is also the number of exterior angles. With that same sense, if you look, all it is the sum divided by n. So now I can get this sum to find one interior angle and divide it by n, and that's going to give me the one interior angle. So one interior angle is equal to 180 times n minus 2, because that's what my sum is, all over n. And you could simplify this more, or you can just use this. I find that students mostly like to just see it this way. So if you'd like me to simplify it more, ask for help in class when we go over the homework for 8.1 of how to simplify that. Okay, so now let's look at where we're going to use this stuff in our homework. So I'm going to turn the page and show you guys some examples. In our homework, we have 4 different things to look at. And the first thing is, our first example is going to go with numbers 13 through 18 in your homework. And it says to find the sum of the interior angles given the number of sides. So all you would do is, let's say that they tell you that, if they tell you that it is a name like a triangle, then you know it's 3 sides. So you need to know what the different names, how many, like a hexagon, how many sides does that have? 6. Now this is stuff you should already know, but if you don't know it, again, it's in the book on page 404. So that table that's on page 404, you can look at it. Okay, so let's look at this. Let's say that they tell you that n is equal to 10. Okay, if they tell you that n is equal to 10, all you're going to do is use your formula. The sum is equal to 180 times n minus 2, and you're going to plug in the 10 in there. So 180 times 10 minus 2. So if you notice, n was equal to 10, so I put in a 10 in for the n right there. So this is 180 times 8. And you're going to want to use your calculator for this stuff, but you need to still show your work. So you need to show the setup of it. Oops. Okay, so I got 1,440, and that's the sum of the interior angles in a polygon. Okay, numbers, our second example goes with numbers 21 through 26. And what this says is given, so it's going backwards, given the sum, I believe, I'm just going to double check. or given just one interior angle. So given an interior angle, measure find the number of sides. Okay, so when we're looking at this, if they're just telling me the measure of 1, then I'm going to be looking at one interior angle formula, which is the 180 times n minus 2 over n. So let's say that they tell me that my one interior angle is equal to 90. Okay, then that means that this 90 will go into place right there. So 90 is equal to 180 times n minus 2 over n. And some of you guys like to see this over 1 because then you can cross multiply, but I know that I can just multiply both sides by n. This is my style of math, so I'm going to do it that way. So 90 times n, these cancel out. 180 times n minus 2. I'm going to simplify the right side because now this just turns into an algebra 1 problem. So distribute my 180, that's 180n minus 360, 90n. Subtract 90n from both sides. It gives me 0 on this side equals 90n minus 360. You guys might have added or subtracted 180 from both sides. Sometimes it's nice to not have the 0 on that side, but I just did it this way because it's just what I felt like doing. Sometimes I do it the other way, it doesn't matter. Now I'm dividing by 90 and n is equal to 4. And if I told you that it's a right angle, then you know that it's going to be a square because that's the only regular polygon that has a right angle. Regular meaning all the sides are congruent and all the angles are congruent. So the number of sides is 4, and that would be my answer. And I'm showing all of my work here. This should be really fast for you guys to do this. Okay, so the next part that I'm going to look at is going with number 27 through 34. And 27 through 34, it's going to give you a picture of some type of polygon, and it's going to have it labeled in the inside. So let's say 3x minus 4 x, and they put degrees like this: x degrees 3x minus 4. Okay, so the first thing that you want to do is you're going to be adding up all of these angles, but you need to know what is it equal to. So this is, how many sides does this have? 1, 2, 3, 4. So that means that the sum of the interior angles is 180 times 4 minus 2, which will end up giving me 180 times 2, which is 360. So I know that if I add up x plus 3x minus 4 plus x plus 3x minus 4, it should be equal to 360 degrees. So adding all this up, I have, this is just simplifying it now. It's just a regular algebra 1 problem. So 6, 7, 8x minus 16 equals 360. Add 16 to both sides. 8x equals 376. Divide both sides by 8. And x would be equal to 376 divided by 8, 47. So that's my answer. It's not degrees or anything like that. It's just a number that would make all of this work. Okay, and then let's look at our last example, which is going for number 35 through 41. And I think these are the easiest problems. So these problems are saying find the interior angle and exterior angle given the number of sides. Okay, so let's say that they told me n is equal to 18. What I do for these, when it tells me to find both the interior and the exterior, it's always easier to find the exterior and then just subtract it from 180, because interior plus exterior equal 180. So let me show you what I mean by that. The interior angle, or excuse me, the exterior angle, to find the exterior angle, it's equal to 360 divided by the number of sides. So in this case, it's going to be 360 divided by 18. So that gives me 360 divided by 18, 20. So 20 degrees is what the exterior angle is. Now, remember, the exterior angle plus the interior angle is equal to 180 because they form a linear pair. So if this is 20, and this is what I'm looking for, my interior angle, and that's equal to 180, then all I have to do is subtract it from the 20 from 180, and I know that my interior angle is equal to 60 degrees. So here's my two answers. My interior angle, or excuse me, not 60, 160 degrees. So my two answers right here are my interior angle and my exterior angle. Okay, and your homework is on your stamp sheet, but in case you like to see it at the end of your lesson, it's on page 407, numbers 13 through 41, 47 through 49, and 53 and 54. The ones that go up to 41 are all of your notes are up here. The other ones, 47 through 54, are just review. So these you have notes for. These are review. Okay, thank you.